Hi everyone. So today we'll be doing lab manual 9 two samples hypothesis testing. Okay, we'll be having two samples and we are going to compare those two samples and then come to our conclusion. Okay, so but what we did in our lab 8 was we had hypothesis value given in the question and then we were supposed to compare one variable with this value and then we used to find out the p-value depending on that, right? Okay, but in lab 9, we will be having two independent variables and we will be comparing with each other because we do not have any hypothesized value here. Okay, so this is the difference between two labs. Here there was only one sample, here we'll be having two samples and we are going to do hypothesis testing for that. Okay, so when we had this as a question, this is how we represented our null hypothesis. That is, mu is equal to the hypothesized value 150, right? But have seen in most of the assignment that the students have represented null hypothesis wrongly. They have used symbols like greater than, less than, in this null hypothesis, which is completely wrong. That makes your question complete. So that makes your answer completely wrong. Okay, null hypothesis will always be having this symbol that is equal to irrespective of the question. Okay, and then alternative hypothesis, this symbol depends on the question. Here it is greater, so I'll be writing it as greater. Okay, this was a question from class activity. Okay, and then in lab manual 9, we have this as a question. I told you we'll be comparing two samples and then conclude the null and alternative hypothesis. Okay, so null hypothesis says that the mean weight of male base is equal to mean weight of female base. You'll be comparing two independent variables. So I write this mu1 and mu2. These are my two independent variables. And then this is the symbol for null hypothesis. It is done. How you will be writing alternative hypothesis? It depends on the question. Here it is greater, so I'll be using greater than symbol. Okay, now it's done. So what is this mu1 and mu2? Mu1 is for males, mu2 is for females. Means mu1 is the mean weight for males and mu2 is the mean weight for females. Okay. So what is the difference between those two labs? So how do we have to choose the p-value in this lab? In this lab, it will be totally different. It depends on the null and alternative hypothesis, not on the question. So how are you supposed to find your p-value? So you used to get some three values which says p less than, greater than, and then p less than absolute value of t. So you used to get those kind of p-values in your lab manual 8. So you were supposed to find your p-value depending on the question. If it is greater than, then you are choosing p greater than t, right? But in this lab, it completely depends upon the null and alternative hypothesis, not on this, but on this. Okay, so to find the p-value, we have to rewrite this null and alternative hypothesis. Okay, so how do we write it? How do we get this conclusion? So here I have proved that mu2 negative mu1, but I can write mu1 negative mu2, right? Why did I do that? Because in t-test, when you do the t-test for the variable, I get this equation. Okay, I'll show you all those things. So first let me complete this. So you have to remember this. If p-value is less than alpha, you are going to reject null hypothesis, which we studied in your lab 8. And if p-value is greater than alpha, fail to reject null hypothesis. Suppose If the null hypothesis is rejected, then in plain English conclusion, we conclude that the evidence exists to support the claim. You have to support the claim if you are rejecting the null hypothesis. If you are accepting, that is, if null hypothesis is failed to reject, then there is not enough evidence to support the claim. Okay, and this was the main thing. If the number of samples is greater than 30, there is no need to verify the normality assumption. Okay, if you get your n values greater than 30, go blindly assume that the variable is normally distributed. If it is less than 30, then you will have to check for normality by plotting the QQ plot, or else you will have to assume that it is normally distributed, even though the plot says if it is if the data points are not near to the normal line. Even though if it is not normal, you are supposed to say it is normally distributed because the number of samples is greater than 30. Okay, so these are the key points for you. And now, yeah, I told you that you'll be rewriting the null and alternative hypothesis, then find your p-value and give the statistical and plain English conclusion. Okay, we'll be doing the class activity question in this video, and in my next video, I will be doing the assignment questions. Got it? Okay, let's do it. So the question says that in lab manual, the question says that we have to test the claim that the mean weight of male base is greater than female base. Okay, so we are going to do it. So go to GNP, open the base file. Okay, because in class activity we will be using this subset. Okay, and while doing your assignment, you are supposed to use this subset of small town. Most of the students are taking the new small town and then doing their assignment, which is wrong. Okay, you are supposed to consider your subset of small town for all the assignments. If you have not one, then you have to create your own subset and then do your assignment. Okay, so let's complete this. So the question says that we are supposed to compare the weight of female base and male base, right? So female and male belongs to sex variable. Go here and check for column info. This should be character. This should be character. Okay, remember this. This is the change you have to do. Choose character, apply. Okay, so sex is done. And now the other variable is weight. Okay, we're going to comparing these two variables. Go to analyze, fit by x. Sex will be in x factor, weight will be in y factor. Okay, done. So what is this? You have did this in the beginning of the lab. This is the parallel plot, right? So one belongs to male and two represents the female. So here you can clearly see that the weight of female or male base is greater than female base, but weight is different and mean weight is different. Okay, mean weight might not be greater than female base. So let's check that. First go here, go to display option, then do the workspace. So just to see the data as clearly, we do this, nothing else. And now, what do we have to do to find the p-value? Go and do this t-test. Do this t-test, and you get 3 values of p. So how are you supposed to choose your p-value now? Okay, so how are you supposed to choose your p-value now? I told you that you will have to rewrite your equation, right? You have to rewrite your null and alternative hypothesis. Can you see or have rewritten it? Okay. So, and then you will be finding out p-value. So, how did I conclude that 2 negative 1? Because see here, this is the equation. This is the key for you. So it says 2 negative 1, then you will have to write 2 negative 1. Okay. If it is 1 negative 2, then you will have to write mu1 negative mu2. So here it is 2 negative 1. So I write null hypothesis as mu2 negative mu1 equal to. Okay, equal to is a symbol for null hypothesis. We are now supposed to change the symbol. It is equal to 0. 0, you will have to apply this for all the question. Okay, and now alternative hypothesis. Mu2 negative mu1, right? Because I got this from here to negative 1, so I write mu2 negative mu1 less than 0. Why less than? The question says it is greater, right? It is greater, but I wrote it as less. Why? Remember, in the beginning, you wrote that mu1 is greater than mu2, right? But when you're rewriting it, you have to reverse the sign. If it is greater, you'll have to do less. If it is less than symbol, it is greater than. Okay. If it is equal to your, then it will be not equal to. Okay. So that is how you have to reverse the sign for the null and alternative hypothesis. Now I have rewritten the null and alternative hypothesis. Then how do I have to choose my p-value now? So remember in your lab 8, depending on the question, if the question says it is greater than, you are choosing this, p greater than t, right? But in this lab, we will be depending upon the alternative hypothesis. Okay, if the alternative hypothesis says it is less than, if it includes this symbol, then you have to say p-value less than t. Okay, you have to choose this value. So I got my p-value, which is 0.06, which is greater than alpha. Okay, so what I'm going to do? Fail to reject. So if I fail to reject, it means, in plain English, it means there is not enough evidence to support the claim that the mean weight of male base is greater than mean weight of female base. So this is your class activity. There is one more question in this. Okay. Um, okay. So we did all these things, and this was the question. Verify the validity. Okay, for proportions, you will have to verify this. For the mean, you will have to verify this. But we are not going to do this proportion thing because the question says only to test for the mean. So you do not have to do this proportion. You will have to do this mean thing. Okay, for the mean, you have to verify that n is greater than 30 or for n is less than 30. You need to check for normality. Okay. I had told you to remember one thing, that if n, that is number of samples, is greater than 30, you have to assume that the variable is normally distributed. If it is less than 30, we will have to check for normality. Okay. Now, how do you find your number of samples here? Where do you get your number of samples? Something bad. Okay. Go to your bear files again. Go to analyze. This is optional. You do not have to do it for all the question. You are going to do only to find your n values. Okay. Says y column. Okay. Okay. I got my n value now. For male, it is 35. For female, it is 19. For male, it is n is greater than 30. So I say that male base is normally distributed. For female base, n value is less than 30, so I have to check for normality. Okay, now close this because I do not need this in assignment. Okay, so we do this only to check the n values. So there is another way to check n values. How? go to tables, sort by. Okay, we'll get one more tabular column in which the male will be arranged. So it clearly says that the 35 number of male base and rest of the things are female. So this takes time actually, so you can go with the first one. Okay, so now go here. Okay, now I'm going to check for normality for female because n value is less than 13, right? So normal quantile plot actual by quantile. So 1 belongs to male and 2 belongs to female. So 1 is for male base. And can you see here the data points are not on the normal line. We still have to assume it is normally distributed because what I got was the normal, the n value number of samples were greater than 30. So I'm supposed to assume it is normally distributed. So you do not have to do anything for this. Okay, it might not be normally distributed now, but after you apply the transformation, it will be normally distributed. Okay, so that is why we assume that for n greater than 13, the variable is normally distributed. And for female base, I will have to check for this because n value is less than 30. Okay, so just omit these 2 points, data points, and check for all the other points. So all the other points are close to the line, are very close to the line. So I can easily conclude that even the female base are normally distributed. Okay, so I say that for n greater than 30, it is normally distributed, and for n less than 30, the female base are also normally distributed, hence the test is valid. Okay, so that is how you conclude the validity of test and then find your p-value. Remember, while finding p-value, be careful. It doesn't depend on the question, it depends on the alternative hypothesis. After you rewrite it, you get one alternative hypothesis, so it depends on that. So this is your class activity in lab manual 9, and I'll be doing the assignment questions. First question in my next video, and then you will have to do the rest of the questions. Thank you.